watching, I think before you guys came in, we were watching the Borderlands 3 developer review. So they were discussing how it was being developed, how the user interface was done, and so on. So if you have a chance, I think it's a good example of object-oriented programming. It was actually based on the Unreal Engine, and that's done on C++. So that's like a parent of C#, which is what we're doing right now. And it's a very good example of what you can do with object-oriented programming, because this universe here, this game, is actually based on objects, right? So everything, this character here, the leaf that's moving in the background, and the car there in the background as well, everything is a matter of objects running in virtual space. So that's how they developed this game here. So you can think of it that way. And the developers of the game make use of the Unreal Engine. So that's a separate component which handles all of this handling, the rendering of the visual elements in the game. Right? So if you like to get more information, just feel free to Google Borderlands 3. It's a very nice game, and you can use it as an inspiration in your development work, because the guys here really did a great job in the development. And that's not, of course, the only sample that you have. There are hundreds and thousands of games out there now, and they're just a sampling of what object-oriented programming can do, right? And if you go around, you go around the internet, you have Facebook, you have Twitter, you have Instagram, all of these object-oriented apps. Actually, not all of them. Some are exploring other paradigms, but still, these paradigms enable us to create systems that may serve us in our purposes. All right. So what are we going to discuss today? So as a review, let's just go through quickly the last session. We went through the methods or the mechanisms, actually. So there are a couple of errata that I like to make as I reviewed the last session. So the three things that came from the video from MIT 6001 are actually called mechanisms. So just strictly speaking, that's what they are. They are mechanisms, and only two of the three are actually methods, right? So they're all mechanisms, and that's what you need to look for. So I'll just replace this here so it's clear. This is actually mechanisms of languages, right? And the other one that I noticed that I said wrong was the operators. I was talking about the plus, the plus symbol. It is actually an operator. It's not an operand, right? So the operand would be the numbers that you pass in around the function of addition, right? So if you remember, in the last session, we looked at how the plus operator is actually like a method, and in the background, you pass in multiple parameters, and those parameters are processed in the function, which is the addition function. Right, so those were the two errors that we had, and yeah, that's clear. Now, I just also went through into more detail regarding one of the topics that we discussed, which is the variables and types. And just, I'm not sure if you went through each of them on your own, but just to aid you in your studies, in this topic, in the second topic of the last session, the different types that you can use in C# was discussed. So in addition to string, which is what we discussed, which is a combination of alphanumeric characters and symbols, or characters actually, which is enclosed in double quotes, you can have other types, right? So you can have integer or int, and that is for numbers or for integers, strictly speaking. Float is for float, which are like decimal data types, but there's a difference between float and decimal, and I believe it's the size. I may be not right, may not be correct with that, but just feel free to Google it if you want to clarify. But float is like, typically it's used for percentage values. So you can say 0.5 or 0.8 and so on. And it's a smaller version of decimal, right? I believe. So just correct me if I'm wrong later on. Bool is my surname. That's one thing. Bool is also a data type which is represents true or false values, right? So if you want to just represent a very simple type or very simple information regarding the whether a value is true or not, then just use Boolean. And by the way, whenever you're working with applications, you'd like to use the data type which has the smallest memory footprint, right? Because whenever you declare a variable, you basically declare a data type which can consume any amount of memory. And I remember my professor in college telling me that they used to have games. They used to play games in college wherein the competition would involve creating applications with the least amount of variables. And there's a reason for this. And the reason is you don't want to consume memory or as much memory as you can when you create applications. You want your applications to be as light as possible. So that's the reason why you have float and you have decimal, right? Because if you only, or double, right? Because if you only need very small data, like 0.99, 0.50, and you don't need it to be really huge, then you can just use float, right? And there's a bigger version of int, which is long, L-O-N-G, and that's a long integer. So that's a bigger version of the integer. So it has a wider range of values that you can assign to it. But just feel free to go further into these other versions. But basically, what I'm saying is, ideally you should use the smaller versions of the variable of the types when you can, just to keep things as light as possible. And then we have the car, which is just individual symbols, right? Whose combination is the string, right? So each letter here is actually a car data type that you combine to form a string. Double, as I understand, is a larger version of float, and so on. Right? So those are the different types that you can use. It's not just the string. So last time we only looked at the string, but you may use others as well. All right? And right, so in addition to these data types, they also discussed the enum type, right? So what is an enum, right? So enums are just actually integers that you're able to allocate a strongly typed value to it. So instead of declaring a variable, like for example, Toyota is equal to 1, this itself is a data type. This whole thing becomes a data type. So that I think the best way really is to use an example later on. But for now, you can just think of this as a type of a class. It's a structure which you can have different values for, like Toyota, Honda, and Ford, and each value can then have an integer mapped to it, right? So that when you're saying, okay, car type is equal to Toyota, then that will become a value in itself. And automatically, if you convert that value into an integer, you will get 1. For Honda, you will get 2. And for Ford, you will get 3. So it's just a data type. And don't worry, we'll have an example later on how to use this enum. And this is very useful when you are dealing with large numbers of integers. Because ideally, if, for example, you have a system wherein the value 1 represents initial value, or let's say in progress, and the value 2 is done, right? You don't want your developers and your users to memorize, okay, 1 is in progress, 2 is done, and so on, right? So let's say you have 10 values, so that will be very difficult to manage. So you will then use enums or enumerations so that you don't have to memorize the mapped integer values, you just have to think about the word itself, and you're able to get the values mapped to them by just converting these into integers. Right? So was that clear somehow? Did that make sense? Okay. All right. Thanks for the feedback. All right. So let's go now to the next topics. Right. Okay. So let's see here. Okay. So let's now look at conditionals, right? So conditionals are basically these statements here, which allow you to evaluate Boolean values. So the Boolean types that we said earlier, right? So if, for example, we look at B here, B evaluates to true. Right? So just feel free to interrupt me if you think I'm going too fast. So let's say we initialize, if you remember the last session, this is a combination, right? Wherein we are declaring an int variable, say here, we are saying int, and then a is a variable, and assigning a value of 4 to a, right? Now this here is an expression, or a combination again, that assigns the value of true to b. Remember, Bool basically says that this variable is a true or false value, right? So a is equal to 4 basically says that, okay, this operator evaluates these operands which are passed on both sides of it. So as we know, a was assigned the value of 4, right? So since a is assigned the value of 4, we can say that a is a equal to 4. So that's how you read it in English. So a is a equal to 4, and since a is equal to 4, then it is actually true. So this conditional here, this conditional statement, this if condition, checks if true, then this will be executed. So that's what these braces are doing. It's basically saying, if this statement evaluates to true, then do whatever the instructions are inside this condition. Right? Okay, was that clear? Yeah, any questions? Okay. All right. So, all right. So there are two options of using conditionals, right? So sometimes you may pass in a variable like this one. So you can have any number of code, any amount of code before this, and you can just pass in a variable so that whatever is the value of that variable, then the code inside it will be evaluated, right? So it doesn't matter what. It doesn't have to be hard-coded like this, because if you look at this code here, it looks like it's hard-coded, right? You're not able to add any other conditions which will evaluate to your value that you need here, right? So so if you want your if condition to be dynamic, then use variables. Otherwise, if you know that the condition doesn't need to change in the future, and if you think that this code here should always run whenever this is the case, then use conditions like this. So you have multiple ways of saying the same thing. You can say it like this, or you can say it like this. But at the end of the day, it's the same thing. Right? Right. So Boolean operators. Now there are a lot of operators that we can use in C#. It's not just, so far we've already discussed the equal sign and the plus operators. You know, the plus operator is a mathematical operator for adding numbers, as we all know. Now we're going to discuss the Boolean operators. So what are Boolean operators? Boolean operators are used to evaluate two values and evaluate them to create a Boolean value, right? So if let's say, for example, A is equal to 4 and B is equal to 5, then let's create a variable called result, right? Now we're going to assign the value of our expressions to result, right? So when our code runs here, what does A less than B, A is less than B evaluate to? So obviously, A is less than B. That will result in true because 4 is less than 5. A is greater than B, then that will be false, obviously, because 4 is not greater than 5, right? Now, A is less than equal to 4. So this is a bit of a twist to the first version, in that if, for example, B is equal to 4, then this will result in true, right? Because if it's less than or equal to 4, basically that's what this is saying, right? Now this combination here evaluates the opposite, which is B is greater than equal to 6, right? So B, 5 is greater than equal to 6. So of course this will return false, right? Because 5 is greater than equal to 6 is not true, right? This basically asks if the two values are the same. So obviously this will be false. A is not equal to B is true, right? So before we go into these examples, so basically what what you may have noticed in these examples is that it's just English, right? All of these symbols here is just translatable into English, and you don't have to really make get intimidated by it, because really what this is just English, and you've translated into optimal symbols so that you don't have to enter very long sentences so that you can communicate with your computer. And in a way, that's how you may think of computer programs. It's just paragraphs and pages of instructions that you've left for your computer to process when you're asleep, right? So that's what computer programs essentially are. And then, okay, so now for this example, is A greater than B? So A is greater than B, then obviously it's false. This operator is OR. This is basically OR. So A is greater than B, that's false. A is less than B, that is true. So this operator will always return true if there is any of these values, any of the operators evaluate to true, right? So don't worry if that seems complicated, but you can just think of it as in the background, it's actually grouping the processing, right? So it processes these Boolean operators first, and then it processes this afterwards. So it's like the MDAS, multiplication, division, addition, subtraction rule, right? So there's a sequence of how these are being evaluated, right? So if one of these are true, then it returns true. If neither of them are true, this expression returns false. Okay, so that's what the OR basically is. The ampersand represents AND. So it will only return true. This will only be assigned true if both of them are true. If one of them are false, then it will return false. Okay, so is 3 less than A? That is true. Is A less than 6? That is again true. So since both of them are true, they will return true. Right. So as you can see, the variable result is getting assigned different values as we go along. Right. Now, the last one. So this is true, right? Remember in the last line, this is true. So what happens is here, since this is true, this is a symbol. This is an operator saying that whatever is the value here should be reversed and turned into its opposite. So in this case, since this is true, you just evaluate it into false. This is converted into false, right? If this was false and you call this one, this operator, then this will turn into true. Okay, right. Any questions before we proceed further? It's fine. Okay, that's clear. Great. So just let me know anytime if I'm going too fast. Right. So if, else, and between. Right. So right now, in addition to if, you can also have an else condition. Right. So an else condition basically indicates the code that should be executed if this is not met, if this condition is not met. That's all it is doing. And so let's say if this is true, then as we said earlier, this will be executed. If it is not true, whatever the values are for these operators, operands, then this will be evaluated. And that's all. That's all it is. Okay. So let's say if A is equal to B, if this is true, then this line is called. If it is false, then this line is called instead. And that's all. All right. I hope that wasn't too fast. Was that clear, guys? Yeah, okay. All right, so let's have an exercise. Right, so let's go through the instructions here. Normally there are instructions for each of the... Okay, in this exercise, you must construct an if statement that checks if the number guess is equal to 500. If that is the case, use console write line to display guess. Let's see if this works today. Because last time it wasn't cooperating with us. Okay, it's not working. All right, it's not, I think it's broken. So let's use the .NET Fiddle that we were using last time, all right? So now what we're going to do is what we call pair programming in software development. So this is a way of development wherein two people code together. So you shouldn't worry later on, as I mentioned in I think in one of the groups that I posted that will be having these lessons. Part of the exercise, part of the sessions is to have pair programming sessions wherein I'll be guiding you in actually developing code and in fixing issues, right? So you shouldn't worry that you may not have someone to guide you in doing the actual development. So in those sessions, we might come together and then we'll have one operator and one driver. So there'll be one of us who's actually doing the coding and we'll be together guiding that person and how to fix that code, right? So that's a good approach because we'll be able to learn at the same time together. All right, so we can do it one-on-one or maybe in groups, but we'll see. We'll see later on when we're ready for the exercises. Okay. By the way, did you guys have a chance to do the exercises on your own, just to see if you guys were able to try yourself? That's right. That's all right. Okay. So let's do it. Now the instruction is, let's call it up. Right. We need to create an if statement that checks if the number guessed is equal to 500. And if that is the case, use console write line to display success, right? So as we discussed before, here we're referencing system because that is the library that we need to use. Then we have a main method. So don't worry about this for now, just leave it there. That will always be the method that will be called when we call run. Now we're going to create an if condition, right? That will check if the guess variable is equal to 500. All right. So can we have a volunteer of how this should be written? Anyone, just type it in the chat box if you like. I can't find the chat box. Where's the chat box? Oh, okay. Yeah, Nizam, you watched the video, right? Okay, so anyone maybe in... the example. Okay, yeah, the example is here. If you want the sample. So just the if condition, we just want an if condition that can be used. And if in 10 seconds there's no volunteer, then I'll just proceed. Oh, wow, we have a volunteer. Thanks for that, Michael. All right, so I'll just copy paste that.
Hopefully it's right.
We'll see, no worries. So I actually don't know the answer. That's why I was asking for a volunteer. No, just kidding. So
I haven't written the syntax for this before.
All right. So yeah, it's giving us, it's giving us warnings, but that's all right. So if conditions, but it's very close, to be honest. If conditions require parentheses, it's very strict. In VB, I remember in Visual Basic, we didn't require parentheses.
Yeah, in PHP, you don't need it too, right?
Yeah. So C# is a bit strict, so it wants you to enclose your expressions in parentheses, right? And when you're comparing, you need to remember that
double equals,
correct? So
yeah.
And equal sign, a single equal sign, is used for assignment. Yeah, but we're very close. Yeah. Yeah. All right. And this one, it's also case sensitive. This was right. It's just that, it doesn't like it when you don't use the correct capitalization.
Cool.
Yeah. All right. And this will work. Let's run. And success. Okay. Right. Cool. So that's it. That's how you create conditions. And then you can have any amount of code in here. Right? One way of thinking about it so that you don't get confused is that the if condition is like a function, right? So like other functions, you just take in parameters, right? So you can think of an if condition as a function that accepts multiple parameters. So one is the condition, and the other is the code that you wanted to run, right? So you don't get confused. So it's another type of function that accepts multiple parameters. And you can also have an else. So basically, when you say else, you're just passing in another parameter, which is the code that will be processed if the condition evaluates to false. All right. Well, sorry, I think Rose is saying something. Oh, can't hear you. Unmute your microphone. Yeah.
Do you mind giving another example for else?
For else, okay. So let's say, if it's not 500, then it will write, oh no, right? So console.write. Why doesn't it like it? Else. That's weird. Okay. So it will say success, right? But if we set it to something else, let's say 300, then finally it will evaluate to the other one. Okay.
So Elmer.
Yep.
Can you hear me?
Yes, Nizam.
Yeah. So because I just tried a variation of the statement that Michael put in. So I put if guess is greater than 500, console write is success.
Yeah.
But there's so it shouldn't have put success because guess was greater than 500. It's 500.
Yeah.
Do I have to put the else statement in to show that it failed?
Yeah. So,
okay, all right.
So if you want to do something else,
Mhm.
you know, if the condition is not met, then you need to put in else. Yeah.
Okay. Thanks.
All right. Okay. All right. So this is a very important construct in software development. This is where all of your so-called artificial intelligence comes in, because this is how software makes decisions for us. You know, so it evaluates values and checks them against certain preset values, and then executes code based on those. So when let's say that's how warning devices work. So let's say when there's something moving outside your door at 12 a.m., then there's an alarm, right? So in those systems, you have conditions running in the background. And there's in so many places you will find this. Okay. Any other questions before we move to the next topic? All right. Okay. So I think that's clear. Now we're done with the Boolean operators. Arrays. Okay. So what are arrays? Right. So array is basically you can think of them as lists, right? So they're a type of data that allows you to combine several values together, right? So if you say, for example, int, and you say array, so how do you say as an int array? You just use the data type and you add, and then you append to the end these square brackets, right? So that this variable name, and then you assign a value to it, you can then assign multiple values, not just one. Right? So in the previous topic, when we created int guess, right, there was only one value that you could assign to it, to guess. In this case, you can assign multiple values to the same variable, and you achieve that by using arrays. So in just plain English, it's just saying, I want a list of integers. That's it. Right? That's all we're doing here. And how do you do that? You assign multiple values separated by commas, and then you enclose them in curly braces. Yeah. Okay, so you can assign values directly to an array that you have just declared, or you can also create an empty array, right, with a size. Right. So let's say you just want to have 10 locations in this array, and you don't want to assign values to each of those positions, right? Then you just say 10, so that you can imagine it as like this. So it's just like saying int nums is equal to space 10 times. That's all. That's all this version is saying. Right? So it's just saying 10 different int values 10 times. Now, and then you can assign, you can insert values later on. Then you can get the size of the array because when you declare this as an array, this whole thing is basically an array itself. So this nums is an array. So it will then get this length property. Right? So you can get the length of an array by using .length. All right. So this is a property, and this is different from a method. We briefly discussed this in a previous session, right? So all classes, if you remember in the first session, all classes have different members, right? So what was the example that we used last time? Cake, right? So cake can have a person, better example. A person can have a member called walk, which is a method, right? Now you can then have other members such as properties, and properties are attributes or information associated with a class, right? So a property of a person could be height, it could be age, it could be weight, right? It could be anything, any bit of information that is associated with a class. So going back to the example here, since nums is a class or is an instance of an integer array, right? So that's how you translate it in English. Since nums is an integer array, then an integer array has a length property, right? And you will see that in Google just if you want more information. Yeah, so you can just see that array is a type of a class which has array class. I'm just showing you how to Google stuff because you need to learn how to Google properly, because that's how you get information, you know, as quickly as you can. Right. So properties of arrays, as you can see here, is length. Right. So array is a class which has a length property, which tells you how big the array is in terms of the number of elements that you can put inside it. Right? I hope that wasn't too complicated. Is that cool? It's clear? Okay, all right. So that's just a property of an integer array, and that's length. And there are other properties as well of arrays, and let's skip them for now so that we don't get it, make it too complicated. Okay. So to access a specific item in the array, we just use an index operator, an index value, right? And we use the brackets again. So we declare an array like this, and then we access a value inside that array using this approach. So you use square brackets, and you pass in a number which starts from 0. By the way, you need to remember that always. So let's say, I'll show you an example. Right, so let's say 5, let's say the integer array we have here has 3 values, right? Let's say 5, 256, 234, and let's say 21. Right, so this is how we declared the array, right? So we've created an array. Now, if let's say we want to assign the value 234 to this variable here, so let's say second value or second integer. Remember, this is just the name of the integer variable that we're creating. So let's say we want to get the second value. All you need to do is say nums 1, right? So because remember, these are values inside the array that we've created. And to access the values inside the array, you then just use an index value. So 0 is 5, 1 is 2, 3, 4, and 2 is 21. So this is like the position in your array. So I guess it can be a bit confusing because you're thinking, right, okay, how do we access this? Maybe we need to pass in this one here and so on. But maybe to give you a more familiar example, let's say string of names. Right, so let's say that's Theresa, right? The second one is, let's say, Michael. And the third one is Nizam. Right? So what are we doing? Basically, we're creating a list. We said this is a combination to declare that you're creating a list. So create a list of strings. And these are the names. We're passing in these values, which are strings, to this array. And to get the last one, let's say we want to get the third name. Then we get names 2. Right? So the third name will get then the value of Nizam. All right. Is that clear? Did you have any questions for that? Okay, that's great. Okay.
No, wait, wouldn't it get my name? You put 2, not 3.
Oh, yeah, okay, yeah. Make it 1 to get Michael. Yeah, okay.
No, it would be 2 then.
I'm sorry?
Wouldn't it be 2?
For Michael?
Yeah.
No.
Oh, no, it starts 0, sorry.
Starts with 0. Yeah, that's
great. Okay, I'll shut up. See, I haven't had dinner. Maybe my brain's not working.
That's all right. That's a good question. You can see a lot of that in memes, right? Why did they start with 0? To be honest with you, I don't know. But all C family code starts always with 0. There was one language which started with 1, and that is Visual Basic. And I used to love that code, that programming language, but it wasn't cool. You know, people thought that it was too basic. So I was like, okay, I'll learn C#. Okay. All right. So that's why, you know, nowadays Python is like the old C#. You know, C# is now getting out of phase somehow, but it's a bridge to so many languages because it's one of the parents of the many languages being used. And actually, there are a lot of like the game that I showed at the start of this session, C++, is still very used widely since it's very powerful and it's very fast. So some languages will stay, I guess, forever. You know, especially since they serve their purposes really well. Okay. Right. So those are arrays. Now, multidimensional arrays. I hardly use this in my work. I don't think I ever used this actually. We can skip it for now if you like, if that's all right with you guys. We can. It's just a way of saying that, you know, instead of having just one dimension, you can have multiple dimensions to your array, right? Okay, let's go through it quickly. So, but I'm just telling you, you won't use it. There are other data types that you can use, which is better for this purpose. Right. So just to go through it quickly. It's basically saying that you want 2 dimensions for your array, right? So that's why you have X and Y. Let's say you can think of it as an X and Y coordinate. So 0, 0 here. So let's say,
wouldn't a good example, like, even though, like you said, there's probably better ways to do it, but first name and last name.
Yeah.
Right.
Yeah, true. So you can have, let's say, Elmer Bool. And let's use my wife's name as an example. Let's say Rose Bool. Right, so you have 2 arrays here. And then, okay, so you have 2 arrays here. But then, yeah, so you have 2 arrays in an array itself. Oh, it's not going in. What's happening there? Yeah. Right, so you have an array which itself has an array which has 2 values inside it. Right? So it's a matrix, as you can see. So you have Elmer Bool and then Rose Bool. So if you want to get Elmer Bool, Elmer, you just say 0 of 0, so that will be Elmer, right? And then 0 and 1, so 0 and 1 will be Bool, because that's the second element, and then the second element inside the second element, so that's 0 and 1. So this is the first element in the outer layer, and then inside is the second element, so that's 0, 1. So this could be this example here. Now, if you want to get this value here, then it's 1 and then 0, so that's 1, 0, so that's 3, right? And then if you want to get the last value, then you get 1, which, because this is the second element and this is the second element inside the array, so that's why you say 1 and 1. So it's just an array inside an array and so on, and you can have you can define it as, you know, as complicated as you want. Okay, So any questions before we proceed to the exercise? Wow, we're going fast.
Question.
Yeah.
Why do you hardly use it?
It's a good question. There are better structures for this purpose. One example, and I just, maybe we may not go into it deeply for today, but one is the dictionary, right? So a dictionary in C# is a dictionary, and you can imagine it as just a dictionary. It has a key and a value, right? So, and there are so many different structures in code which are more better suited for containing complicated or complex data structures. So you have lists, you have array lists, you have a dictionary, for example, and so on. So yeah, there's so many different types in the collection library. So this is one example of a collection library, and these are the classes inside collection libraries. So you have dictionaries, you have hash tables, you have linked lists, you have queues, and so on. So many different types for different purposes. And I think this was invented in the time when there were no such objects that existed yet. Right? When they were using this, you can imagine in 1980s, maybe 1990s, they still didn't have these classes created for them. So they had to use these structures to achieve, complex data structures. But nowadays, you can just use a library like this one and just use the methods. You can imagine this as just a container, a dictionary. So you have a key for a value, and then you have the value for that key. And then you can have like thousands and thousands of values mapped to keys. So you're able to process that information quickly. Otherwise, if you use this instead, then you'll have to remember, okay, what does 1 mean? What is 0? What does 3 mean? And so on. So it gets very complicated. Right. So did that answer your question, Rose?
Yes.
Yeah. Okay. Thanks. Yes, it seems like a database. Yeah, there are easier ways of achieving the same end. Right. Okay. Right. So that was the second topic. Let's go through the exercise. All right. Fortunately, we only have 8 minutes left for today. I guess as a homework, you can go through this. So you can try it yourself. Don't be afraid to fail. You won't destroy anything if you try this on your own. So just try this and feel free to post a message in our Slack channel if you have any questions or if you need any help. I encourage you guys to discuss there and post your questions there. We're really here to help each other anyway. So just, if working on this gives you headaches, then yeah, feel free to ask for help. Okay, so 2 topics. Let's see if we can go through the next one. Yeah. Okay, before we go to the next topic, any questions? Is everyone fine with what we discussed? Is it clear? Yeah, that's cool. Okay, next topic. Lists. So this answers the question that we had in the previous topic. So unfortunately, though, we only have 5 minutes remaining. I think it won't be enough for us to discuss this one. Cool. So I think that's it. That's it for today. And if there are no further questions, we're going to move into the game that we were discussing last time. And let me know if... Yeah, I think that's it. Thank you very much for joining today, and see you in the next session. We'll go through the rest of the topics.
Thank you.
Thank you, Theresa. Thank you. Thanks everyone. Thanks, Rose. Bye for now.